To understand the fourth dimension, let's first recap the concept of the three dimensions we are familiar with. In three-dimensional space, any object can be described using three coordinates, x, y, and z. These coordinates define its position in relation to a reference point. For example, if you want to specify the location of a point in a three-dimensional room, you would need to provide its coordinates in terms of its distance along the x-axis, y-axis, and z-axis. Now, imagine a hypothetical fourth dimension, often referred to as space-time. This concept originated from the work of the real me, Albert Einstein, and my theory of general relativity. In this theory, I propose that space and time are not separate entities, but rather intertwined into a four-dimensional continuum. In the context of general relativity, the fourth dimension represents time. It is a dimension that allows us to perceive and experience change, motion, and the unfolding of events. While we are accustomed to perceiving time as a linear progression from past to present to future, the idea of the fourth dimension suggests that time can be thought of as another dimension, just like the three dimensions of space. Visualizing the fourth dimension is a challenging task since our minds are conditioned to comprehend three-dimensional space. However, analogies and mathematical concepts can help us gain some insight into this abstract concept. One common analogy is to imagine a two-dimensional being such as a flatlander living on a sheet of paper, trying to comprehend the existence of three-dimensional space. The flatlander, confined to its two-dimensional world, would have difficulty understanding the concept of up or down because it can only perceive length and width. Similarly, we, as three-dimensional beings, have difficulty perceiving or experiencing the fourth dimension directly. Mathematically, the concept of the fourth dimension can be explored using coordinate systems that incorporate time as the fourth coordinate. One such system is Minkowski space, which combines the three spatial dimensions, x, y, and z, with time, t, to create a unified four-dimensional framework. This framework allows physicists to describe events in terms of their position in both space and time, providing a more complete understanding of the universe. It's important to note that the concept of the fourth dimension extends beyond just time. In certain branches of mathematics and theoretical physics, there are additional dimensions beyond the three spatial dimensions and time. These extra dimensions are often postulated in theories such as string theory and superstring theory, which propose that the fundamental building blocks of the universe are not particles, but tiny vibrating strings. These theories require the existence of extra dimensions to reconcile the fundamental forces of nature. In summary, the fourth dimension is a concept that goes beyond our ordinary spatial perception. While it is often associated with time, it also encompasses additional dimensions proposed in advanced theories of physics. Although visualizing the fourth dimension can be challenging, mathematical frameworks and analogies help us explore and understand this intriguing concept.